Welcome to the series I'm going to call Sciencing, in order to help you better understand scientific research. This module introduces you to case control studies, a type of observational study design. And please see the module Introduction to Quantitative Research Methods if the meaning of observational in the context of research is unfamiliar. I cover it there. Case control studies address questions like, is a specific exposure, for example, smoking, obesity, or exercise, mathematically associated with a specific outcome, for example, lung cancer? Case control studies compare cases and controls. A case has the condition of interest. For example, an infection of a specific kind, a specific cancer, a specific type of injury, or some other characteristic. Whereas a control does not have the condition of interest. That does not mean they are healthy, they are free of injury, free of disease, but they don't have the condition of interest. So exposure in cases is compared with exposure in controls to see if there is a difference in terms of what proportion in each group were exposed, and or to what extent they were exposed. So it could be simply a yes-no for any given individual, or it could be an amount. Cases and controls are often matched for recognized risk factors. Things we already are relatively confident increase the risk of the condition of interest. In other words, things known to be, or at least thought to be, associated with the outcome of interest. For example, age, sex, maybe body mass index, so that's a weight for height indicator. And it could be any number of other relevant things, because we want to know if the exposure the study is assessing is independent of these other known or strongly suspected risk factors. Now, this approach is far from perfect, and overmatching can become a bad thing, meaning we make people so close that we kind of miss the key detail. But that level of detail is beyond this module. It's almost an area of expertise of itself. Case control studies do have some advantages. As they tend to rely on existing records or participant recall, they're relatively inexpensive and relatively fast. Case control studies are also particularly good for rare conditions, as the researcher can select people with the condition of interest, unlike in cohort studies, we'll talk about in a future module, in which participants having or developing a condition is a matter of chance. So not many will likely develop a rare condition. As with all observational studies, case control studies help generate hypotheses that can then be tested using experimental study designs. It's important to remember that correlation does not mean causation. Even if a big difference to an exposure is observed in the cases versus the controls, and this is found to be statistically significant, it doesn't tell us whether the selected exposure caused the condition of interest, was caused by the condition of interest, or if the two are somehow related to a third important factor, but actually don't directly influence each other at all. Consider this example, and feel free to pause the video so you can have a good look. It turns out that the number of people who drowned while in a swimming pool is closely correlated, very closely, so the best correlation you can get would be 1.0. So 0.9 is up there. Was closely correlated to how much US power is generated by nuclear power plants. But hopefully you'll agree that does not mean that power generated by specific means causes people to drown. At the very least, we would require closer investigation, whether location matters as well. So So this is one of many good examples you can look out. Correlation does not equal causation. You'll probably come up with many graphs like this. Beyond not being able to demonstrate causal association between exposure and outcome, case control studies also have other limitations. They can only assess one outcome, as the outcome defines the case themselves. This study design relies on existing records or recall that may be incomplete or inaccurate. And recall bias may also be a problem. If participants are relied on to provide information about past behavior, for example, if the cases are defined by a diagnosis of lung cancer, the same people, the same cases, may overestimate how much they smoked in the past, whereas smokers among the controls who do not have lung cancer may underestimate how much they smoked in the past. Case control studies are also particularly bad when trying to assess the temporal relationship between outcome and exposure. For example, did A come before B before A, or did they come at the same time? If you found this useful, hit like, hit subscribe, and most importantly, keep learning by watching other modules in the series, including maybe the one here or here.